Hello everybody, welcome back to my channel and welcome back to yet another exciting and original content on Technovation. Let me start today's session with a question. How many of you as a data engineer have worked on upgrading existing data interfaces? You might have built a feature, you have tested the feature, you have taken all necessary approvals, but then when you finally take your upgrade to production, your interfaces start breaking. And as a data engineer, I'm sure that's not a welcome news, and you all have gone through that particular phase. When you start deep diving, you find out that your new features have absolutely worked great, but your consumers are complaining that your existing features are breaking. Some of the existing features might break because of data type issues, whereas some of them are complaining that, hey, your numbers are not consistent. Well, this has primarily happened because while you were absolutely focused on testing your new features, you forgot to ensure the fact that you have to deliver an interface where existing functionalities are not touched. And that is where regression testing comes into the picture. Ladies and gentlemen, this brings us to the topic for this session: automated regression testing in a data engineering ecosystem. So, how do you perform your regression tests? I have been doing it for the last 17 years, and let me take you through that evolution. In the initial days, I was copying data from the databases over to spreadsheets, write a bunch of macros, virtual lookups to compare the data which is residing on two different tabs, cell by cell, row by row, just to find out where they are different. Well, this seems easy, but this had two major problems. The first is compliance. Because the moment you copy 500,000 record out of your database to your spreadsheet, the compliance team is going to come after you and say that, hey, this is a security threat, you cannot do that. The second is scalability. Think about a time that it will take to repeat this exercise across 10 different objects with 500,000 record in each of these objects. This is not scalable at all. Fast forward 5 years, I started writing Python in Jupyter notebooks. I had the flexibility to automate it, to optimize it using pandas. But then the first problem was still there because I was still egressing a lot of data from the databases over to my Python runtime wherever they were. Either it was on my laptop, maybe it was on my virtual machine, or maybe on my containers. I was still copying a lot of data out of my databases. Now, I had to live with this for some time because none of the databases back then had a Python runtime adjacent to your SQL runtime or within the database. But sometime around 2019 and 2020, Snowflake came up with this wonderful framework called Snowpark, which allows you to use your Python runtime adjacent to your Snowflake SQL runtime all within the Snowflake ecosystem, or maybe to be precise, the Snowflake Virtual Warehouse. The Snowflake Virtual Warehouse allows you to run your SQL and your Python all within the warehouse. There's no need to bring data out of Snowflake to do this. So today, we're going to focus on a regression test framework which can run your SQL and your Python all bundled together within Snowflake. Now, before I end, let me talk about a little bit of DBT. Because if you have worked on Snowflake for at least 1 year, I'm sure you have heard about DBT, and we're going to use this fantastic transformation engine to wrap up our regression bundle. We're going to create a Python model. We're going to use that Python model all within Snowflake to run our regression tests in an automated, cost-optimized way to get our results done. Thank you very much. See you in the very next section where we start with a small demo and then look at the code in action.
Thank you very much for joining me in this section of the video. I'm going to take you through a very small demonstration of the final outcome so that you are very well aware of what is coming up. Now, the regression framework that I've built, it has primarily two validations. Number one, the data type validation, and number two, the data validation. Now, these two are two disconnected validations. Well, you can run one after the other, but then there's no mandatory sequence. You can run one after the other or one before the other, doesn't matter. On my screen, you are seeing the sample data product that I've built. I've named the project as sample DBT. I'm going to clear my screen and straight away get started. So the first thing that I'm going to run is my data type validation. Now, in this particular example, at least as of now, all the configurations are already set up. So I just wanted you to get a flavor of how the output is getting displayed. So I'm going to run the first model, which is dbt run -- target. In this case, the target is regression. And then I'm going to say which model to run. I'm going to run the first data type model, data type underscore validation. Let's type in that data type underscore validation. So what is it going to do? It is going to compare the data types of a particular object between two different schemas. If it is successful, it is going to return the results in the table as saying that data types match. If it is not successful, it is going to tell you what is not matching. It takes a little bit of time, and yes, it is successful, but then it is not going to show you the data over here. So what it has done is, if I go to my Snowflake, if I go to my sample DBT, let me enlarge the screen for better visibility a little bit. I can take you to the table called data type validation, right? You see this data type validation? So this is a table which was created when the validation program ran. You can see it has failed. And if you click on this particular one, you'll see that it is because this particular column called region had a difference in data type between two different schemas. And that is where it failed. So it not only told you that there's a difference, but it's also told you where the difference is. Fair enough. At this point of time, I'm going to go and run the next model, which is regression execution. What it is going to do is it is going to compare the data between two tables which are residing in two different schemas, compare them row by row, cell by cell, and it is going to come and tell you whether they are a match or whether there is any difference. Now, this can take a little bit of time depending on the number of objects and the number of records you have in each of this object. For demonstration purposes, right now, I have only one object that is participating over here. Now, how am I controlling the number of objects is again based on the configurations that I have done. I'm going to go through the configuration in detail in the next section of the video where we build everything from scratch. Fair enough. So what it has done is, I'm going to move my video a little bit. It has created a model called data validation regression execution. So in DBT, if you're working for the first time, what it does is if you execute a model, based on the materialization strategy of the model, it creates either a view or a table in your database. Let's go ahead and take a look at it. I'm going to come over here. Okay. I think I'll have that particular query somewhere. Let's take a look at this one, right? Regression execution. Now I have the column names over there. I'm going to call out, I'm going to say star, right? Let me see what it has done. It has actually created a table called regression execution, and it has all the logs, whatever it has done, because that is the way I have created the framework so that as a developer, you know each and every step what has been performed. And finally, at the end, it tells you that the list of models processed for regression. If you see this, the list of models processed for regression, um, this is what it says, the list of models processed for regression. Now, if I go to this table, I should be able to see again in my validation schema. In my validation schema, I will have a table called, um, yes, select start from validation regression, validation underscore regression, annual sales by region. If I select this, the results of the validation are stored over here. What it says is the data frames are equal. So what it turns out, this particular model has a difference in data type in two different environments or two different schemas. However, the data which is there in these two tables or models, they exactly match with each other. Well, it's very much possible. There can be a number which is saved as a number in one table, and the same number is saved as a VAC in another table. If you do a data comparison, it will exactly match. However, uh, this becomes a great candidate for your regression because while your data is consistent across two different environments or two different schemas, your data types are mismatched. So checking your data types are equally important along with your data. Because in this case, if you have a Tableau report which is running based on this particular database or this particular schema, it's going to break because there will be a difference in data type, right? So that's what we have built. That's what I'm going to show you. There's another model called regression outcome. So if you run regression outcome, you will see that it actually aggregates all the information which is there in all the tables which has participated. Now, I'm not going to waste much of our time in executing regression outcome because anyway, we are going to see everything in detail. We're going to open up each and every model, look at the code and get it into action in the very next section. Thank you very much. See you in the next section. So we are in the next section of the video. By now, you have got a complete understanding of what we are going to build and how the final outcome is going to look like. With that, let's get started. So the first thing, I'm going to take you to my Medium blog. So here is a Medium blog. I am going to leave the link in the description box, and I sincerely request you to go ahead and read it. Now, let's spend a minute on this particular diagram. So as you see, I have a Snowflake database, and I have two models, rather two versions of the models coming from two different branches. First is my master branch, which is creating model version 1, and then I have the release branch, which is creating model version number 2. Now, when model version number 1 is getting executed, it is getting the models are stored on the schema. It can be the staging schema, it can be the March schema, it can be any other schema, or it can be both. On the release branch, what it does is it creates a schema with the name of schema name underscore regression. And the regression package is going to compare the datasets between these two schemas, the source being the same, right? So that's what is my data product going to do. Now the data product is going to import the DBT reusable regression package and get this thing done. So this is what we're going to build. First, we're going to work on the master branch. Then we're going to switch over to the release branch, make some changes, then import the DBT reusable regression package and try to see whether the changes are identified rightly by the DBT regression package. Fair enough. Let's get started. It's a very simple data product which I have already created just to save a little bit of time. It has two models. One is a MART model and one is a staging model. Now the business logic is not very important out here because we are not going to see how DBT business logic is built, right? We're going to see the integration with our regression. Now I have a very simple staging model which is going to read the data from the seeds file, which is nothing but a sample data which I created using AI. I have a sales base table, and then I am doing some aggregation based on two attributes, which is sales year and sales region. Now, sales year and sales region is not something which you will find on the sales data table. It is there in the staging layer where these three are Sales year, sales month, and value tied. These are derived attributes. Fair enough. The first thing that we're going to do is I'm going to take you to my database first. Let's go to my database. On my database, you can see that there's a sample data project, but then I don't have any schemas right now. It's a brand new database which has been created. Great. What I'm going to do, I'm going to run my DBT seeds first, but then I think I missed something. I did not speak about this particular macro. So I've also created a macro which just creates a custom name, because if you do not have this macro, what DBT will do is it will put a staging at the end of the schema, which I don't like. Then it will become staging underscore staging, right? So that is the reason I have a custom schema created out here. Now, this custom schema has a lot more meaning when we go to the next section where we are going to build the regression. But for now, the regression thing is not there. It is just using a custom name, which is my target name. So I'm going to say DBT seeds hyphen target sandbox. Why is it sandbox? Because if I go to my profiles, you can see I have my output labeled as sandbox. Now it can be prod, it can be pre-prod for your case, or it can be dev, anything. Fair enough. I'm going to get this executed. I think I made a spelling mistake. Yes, it got to be DBT seed. Yes, we're good. It is creating a table called sample sales under the staging schema. If I go back, refresh it, and you will see that there's a table called sample sales. If I want to take a look at the data, I think I have it somewhere. Do I not have it? Yeah, select base. Not this one. I'm going to say sample sales. Perfect. This is the data we just loaded. What's next? It's time for us to run our DBT models. I'm going to say DBT run hyphen target sandbox hyphen select the models staging marks. It should create the two schemas, staging and mart, and it is going to load the data. Yes, staging and marks. If I again go back to my database, you should be able to see staging and marks. You can see sample base is created. So if I go ahead and run this particular select statement, you should be able to see, okay, I think I missed this semicolon out here. Perfect. So my staging is created, and then if I call it, if I go to March, I should be able to see this. Fantastic. What's next? Now it is time for me to create a copy of this main branch, assume that it's going to be my release branch, and make some changes out there. Fair enough. So this is your production. Now I'm going to create my release branch. Get branch YouTube underscore demo. Right? Okay, it exists. So what I'm going to do is I'm going to say, let's say, I'm going to name it YouTube walkthrough. YouTube walkthrough. Fair enough. It got created. Now I'm going to switch over. Get switch YouTube walkthrough. Clear it up. Fantastic. The very first step is something that we have to get this schema name updated, profiles updated, and then I have to import the package. Now, where are these steps documented? That's the question, right? So if you go to my DBT Git repo, which I have already made it as open source, you should be able to see. So under DBT Snowflake regression test, if you go to my README file, a lot is written. Everything, whatever I'm speaking about, I have taken ample amount of time to get this documented. So I'm sure you are not going to face any difficulty in going through each and every step and get it implemented. Project artifacts are implemented. And then finally, I have the implementation steps. Now I'm going to go through the regression models code in detail, but then I really want you to understand the implementation steps, because without understanding the implementation steps, you will never be able to set it up, right? So the first thing that I'm going to do is copy this particular model over, sorry, the macro over, come to my walkthrough branch, and I'm going to replace it. So what is it doing? The previous definition of the macro had just a custom name. Here in the new branch, what I'm going to do is I have mentioned that if the target name is regression, then append regression. Because as I said, I have a staging schema and a match schema. To do my regression, I need to create a copy of the data from the same source and using the modified models. So I need a different schema to save it. I might do it in a different database altogether, but this particular framework does it within the same database and in a different schema. So what's the next step? I've got my macro updated. The next thing is I'm going to import my profiles, right? Because this is where the import is going to take place. So what I'm going to do is I'm going to create a file called packages.yml and add this. So it is going to add a dependency with my GitHub repo. I don't know. Before I run dbt deps to actually get this imported, I'm going to go to the third step. Now you can skip it, but I just wanted to go to the third step because I wanted to add this regression piece, right? Because if you see on my profiles, I have the sandbox. Now don't worry about the username and password. Anyway, I'm going to change it and it's a trial account. Now the sandbox resides. Now I need another output section or another target section, which I'm going to name it as regression. And that is what it says that, you have your output and now you have to create something called a regression, because without this, you cannot instruct DBT to create a different schema and then go ahead and execute the entire package in that new schema. So I'm going to paste it out here. I think I need to do a little bit of formatting because YAML is very, very sensitive about formatting. Yes, there I am. No, I'm not even there. I have to come to the sandbox level. So yes, there I am. Now what I'm going to do is, because it's the same, configuration, same credentials, I'm just going to copy over them. Username is going to be my developer. Temporary access is going to be my password. I have my role, which is account admin. Database is sample DBT, warehouse is compute warehouse. Schema, let it be staging, I don't care. Threads, this one is going to be my regression query tag. Now, I'm not going to use query tags out here, but it's always a great practice to use a query tag, because when you debug your code, you might have to go back to Snowflake and see that, whether your SQL has done the right job or not. Now, when you go to your Snowflake query editor, you find a lot of queries in your query history, right? So if you are in a multi-developer environment, how do you find out which queries are yours? It's very easy to find out by the username, but there's another way by your query type. Fair enough. Now, at this point of time, what we have done is we have completed up to step number 3, but then we did not run the DBT packages, right? So I'm going to close it, close this, go up, and then I'm going to say DBT depths. So it is going to do my import. Perfect. It has imported the package, and you can see on the left hand side, the DBT underscore packages folder is there. You have your macros, you have your models, um, and the rest of the things. Now, what's next? The very next step is to get your release notes. Now, what is a release note? A release note is a file which tells the package what are the things that has changed in this current release, because you are doing a release. You need to make some release notes. Now, how do you prepare the release notes? To prepare the release note, you can do it in 2 ways. You can manually type it, because if you have the patience to manually type it, fair enough. Or else the other way to do it is use MCP. So for that, first thing is that we need to make some changes. So I'm going to go to my DBT model. Let's say I'm going to make some changes in my MART layer, and I'm going to make some changes. What changes? Very simple changes. Let's say I make this changes number. This 30,000 becomes 50,000 becomes 40,000. Yeah. So anyway, this is a derived attribute, and I am going to categorize the difference performance tiers as high performance and medium performance. What I decide is I'm going to alter the definition of my medium performance, which is becoming 40,000. I'm going to save it. Perfect. What's next? So my changes are done. I need to find out what has changed. But before that, I need to execute my package. So if I do a clear and if I execute my package, the modified code is going to be executed on top of the same source data, which is my sample sales, because I did not make any modifications there. Let's go ahead and do it. So I'm going to say dbt seed hyphen hyphen target, and this time I'm going to write regression. What is going to happen? The dbt seed file is going to be loaded in the staging underscore regression schema. Let's see whether it does it or not. Yes, it did it correctly. So under my staging underscore regression schema, the same source file has been loaded. Let's go ahead and check it out. Sometimes you might feel that I am a little bit in a rush hour, but I really don't want to extend this video more than an hour. So that is the reason I'm speeding up at certain point of time, but then you always have the luxury to go back and review it again. Now, if I go to my staging underscore regression folder, I can see same sample sales. Perfect. Moving forward, I'm going to run my DBT package. So I think I ran my DBT package something back. I'm going to modify the same statement and just mention a regression. Perfect. Same copies of the model will be executed with the modified code in 2 different schemas. Staging underscore regression, which was already created in the previous seed run, and now Mars underscore regression. So this is how is the state of your database after step number 4. So I have the staging and staging underscore regression. I have Mars and Mars underscore regression. Let's go back and review the steps. Now it is time for my release notes. So what I'm going to do is I'm going to raise a pull request. And then I'm going to utilize the pull request and go back to my cursor and ask cursor that, hey cursor, based on this particular pull request, why don't you generate a release note for me? Fair enough. Now I'm going to clear it up. I'm going to say git add. Let's say git status. What are the things did I correct? I have updated the generate schema. I've updated a model, and I have updated profiles and packages as well. Now it is time for me to commit it. git commit -m made changes for the current release. That's okay. Okay. Now I have to push this. So let's say git push -u origin and then my branch name. So it's YouTube walk. Now, let me tell you, all these setups are required only for the first time you are going to execute regression. You don't need to do everything every time because you already have a copy of it in your data product itself, right? I'm going to push it through. I hope it goes. Yes, it is done. Now, if I have to go to my sample DBT project, I can see that there's a push already happened. I'm going to compare it and I'm going to create a pull request. Because this is the pull request which I'm going to use to create my release notes using my MCP. Now, MCP is a great tool. However, I'm not going to show you how to set up GitHub MCP. There are a lot of tutorials, a lot of README files, and maybe, if I am correct, GitHub has their own GitHub repository which talks about how to set up, GitHub MCP with your personal access token. I'm not going to do that for you, but then I would sincerely request you to go ahead and try MCP servers. But then mine is a paid version of Cursor. So if you do not want to invest money on Cursor, then you will have to make it on your own. But let me tell you, it's not at all complex. It is very, very easy. But then the complexity increases when the number of changes that you make in your release increases, right? So that is the reason um, GitHub MCP comes to your rescue. Now I'm going to create a pull request. I'm going to commit. Anyway, I'm not going to merge it. So if I go to my changes made in the current release, if you see what are the changes that I make, changes to my generate schema, which is not important for me, changes to my model. Yes, if you see 50,000 has become 40,000. And this is exactly what I want my MCP server to identify. Fair enough. Now I'm going to move over to Cursor. I am going to configure my MCP because Cursor is my host. I'm going to configure my MCP server, which is already done, by the way. And I'm going to ask Cursor to create this release notes for me. Okay. And take this pull request number 5. This is what we're going to use. Okay. See you on Cursor. So I am on my Cursor app now. You can see that I have already logged on to the branch YouTube walkthrough. And I'm going to figure out, let me tell Cursor, just a preparatory note. Hey, can you study the package, the DBT package? Let it get the context because it's very important for it to get the context. Otherwise, it will not be able to understand my next prompt. Now, moving on, while it does it, what I've done is I've already created a prompt. Now, this particular prompt is already available in the GitHub README for you to refer. You can just use the same prompt. What did I say? Can you find out the changes in the data model that I have done on this GitHub pull request? So you can see there's a GitHub pull request that I have raised. This is the pull request that we just raised. Once you figure it out, use the release template in the folder. DBT packages release template. So there's a release template. Moving forward, there's a release template. You can see under DBT package, there's a release template which got imported from the regression package. I have the release template out here. It says the model names, column names, and descriptions, versions, and there are a few comments as well. Okay, so there's a release template. So what it is going to do is it is going to use this release template, take the details from the merge request, and it is going to create a release file for you. Where is it going to create the release file? It is going to create the release file under releases of root. So it is going to create a release file under the releases of this root. Now, what we can do is, now cursor is going to ask for creating the release folder. Now, you can give cursor the permission to create it, but for the time being, I'm not going to allow cursor to do it. I'm going to create the folder myself, releases. So what is it going to do is, it is going to go under DBT packages, read the template, get the details from your GitHub, and fill in the details in a new release notes file. Now, the next thing that we're going to talk about is configuration of your MCP server. So if you go to cursor and then cursor settings, I can show you that my MCP is already configured. GitLab, I have disabled it for the time being, and then I have GitHub, because the version that I use, it doesn't allow too many MCP servers. So for the time being, I have disabled GitLab and I have enabled my GitHub. Fair enough. Let me close this, and it has done it. Now I'm going to copy this and I'm going to paste it out here. You can see the magic happening. Okay. Here number 5, it has found out. You can see this. Fantastic. It is already identified performance tire. You can see lowered from 50,000 to 40,000. It is going to create this file, release version 1.0. Wow, perfect. It has done the job. Let's go back. Let me close this. Let me go to releases, and I can see release version 1.0. Did it do it rightly? Yes. You can see that I have made the change to this particular model alone. And which column got affected? The performance type. So this is a nice and easy way of doing it. However, if you do not have access to Cursor or Claude, you can definitely create this manual. Fair enough. Now that we have used Cursor and we have this release notes, let's head over back to VS Code and follow the rest of the steps. So now we have switched over our editor from Cursor to VS Code again. We have the release notes file out here. Fantastic. What's next? Let's go back and take a look at the next step. Now I have to create the regression config. Now, what is regression config? While you read this on, which is there on the screen, regression config is a file, is something which I as a developer want to define my scope of regression. Now, release is the current scope of regression, but the overall scope of regression, which are the models, how do I want to manage the volume that it is going to take part in the regression process, is something which I want to define. So in this particular case, if you see, I have a regression config file. Now I need to create this regression config file. How do I create this regression config file? A template is already available. I just need to move it over. Okay. So now let me go over here, go to my DBT packages, and I can see that the regression config file already available. Okay. I'm just going to drag it over outside this package under root. Under root, I have my DBT regression config file. So I have the name, database, schema, filter name, operator, and the filter column value. Now I can have a lot of model names out here, but for simplicity, in this current data product, I have only one model which is going to participate in the regression process, which is my MART model. I can put my staging models as well, but in reality, if you think, you generally do not require your stagings to participate in your regression, because staging models are not your presentation layer. Generally, your presentation layer models participate in your regression. But then if you want staging models to participate, there is no limitation. You can always do that. So what I'm going to do is I'm going to just remove this and paste this. Okay. And I'm going to take this part out because this is not meaningful out here. In the example itself, I have actually intentionally put the actual model names and the file names. So I have the model name out here, database name, the marks is the schema name, and the filter. Now, why do I need a filter? I don't actually need a filter in this particular case, but I wanted to show you that it is possible to put some filters because that's how the package is written. Why do I need a filter? Because if you have, let's say, data of 10 years, is 10 years historical data in this particular model. Do you want all the 10 years data to participate in your regression? Well, you can, but then it is not required because it's going to take a bigger warehouse, a longer time to execute. You really don't want to do that. You want to take a subset of the data and you want to execute regression by comparing the results of those two subsets across two different models. That's what you actually want to do, right? So that is the reason I have put a filter column on the sales year equals to 2024. Okay. Now, if I remove this, the model is going to run fine, just that the execution time is going to take a much longer time. It might also break because I'm using an extra small warehouse out here. I might have to move to a medium or a large in case a bigger one is required. Fair enough? Let's save this. Now, what's next? The next is upload the config files. So I have two config files. One is the regression config file and one is the release config file. Now, because DBT Python models are nothing but Snowflake stored procedures, finally at the end it is a Snowflake stored procedure, right? Now, Snowflake stored procedure cannot read your local files or your files which are there on your DBT repo. It needs files to be there available within Snowflake, and the only mechanism to upload files within Snowflake is through a stage, whether it's an internal stage or an external stage. In this particular case, we are using an internal stage. Now, if I go to my DBT package, if you go to my macros, there's a file called push config. Before I execute it, I actually wanted to show you this. So what it does is it actually creates two schemas and a stage name called config, and it pushes the file from your local machine, which is your MacBook, to your Snowflake stage, right? So put file, stage name, and then put file, again the stage name. These two files will be pushed. And which are these two files? You can pass on the name of the files out here as arguments. So I have the release notes files and I have the config files. At this point of time, if I go back to Snowflake, you will not even see the validation schema. So the validation schema doesn't even exist, right? Because it is going to create the stage in the validation regression schema. Let me clear this out. So my next job is to execute this particular macro. Now, executing this macro needs a little bit of minute syntaxes. So for that, what I've done is I've already written this statement. Let me go back to my editor. So you can see that there's a macro statement already written up. Let me copy it over and push it here. And then let me run you through this. So what I'm doing is DBT run operation, push config. This is the macro, target regression, and then I have to pass the arguments. As I said, the first argument is a release note. So where is the release note? Release notes file, that's the name, and the value is under release notes, release note 1.1.json, right? So this is something which I need to change because right now I have 1.0, right? And then I have the regression config file. Where is the regression config file? It is there in the root directory itself. So I need not point out any specific directory path. And it is done. Now, the moment I do it, see what happens. Perfect. It is executed successfully. Let me go back to my database and check it out. Wow. You can see that the validation regression schema is created and there's a config stage. Let me go ahead and execute No, not this one. I'm going to say, so Snowflake has recently changed its workspace, so I am still coping up with the new changes. So what I'm going to do is sample DBT, database, validation, regression schema, config. Let me see what are the files which have been uploaded. And you can see two files have been uploaded, the regression config and the release notes. Fair enough. We are moving forward steadily. Next. Okay. So we have the data in our staging underscore regression and the Mars underscore regression model. Let's move over to the next step. The next step is going to take us to the execution of the DBT tests. Now, before I run the regression tests, what I need to do is I need to ensure that the new models, I'm on my DBT project and I'm going to paste it over here. I'll just tell you in a moment what am I doing. Right. Now, this is very much required because for the sample DBT project, I had directed my marks and stagings to have this schema name, marks and staging schema name, right? However, this is a new project because this is the imported project. And if you look at the folder structure, you will understand this is a new project, which is DBT Snowflake regression test. This is not a part of my sample DBT. Now, because it is an imported project, I need to call out specifically that the models inside my imported project needs a separate type of a treatment. That is where I'm saying it's a validation. Then the schema is validation. And then I have, sorry, under this, you can see the models are under validation. That is why validation, schema, and macros. Fine. Now it is time for me to run my regression models. Let me go ahead and run them. Yes. So DBT target regression. I'm going to run this. Did I save it? Let me save it. Now, while this runs, let me give you a little more background. So DBT Python models are nothing but stored procedures. So what it is going to do is it is going to do a check whether the version of the DBT model which is there on the Snowflake stage and which is getting executed now, they're same or not. If they're same, that's fine. If they're not same, it's going to overwrite. It will do a create or replace. So create or replace takes time. So you will see that the execution time of a DBT SQL model and the execution time of a DBT Python model, they have a lot of differences in them. Yeah, the DBT Python model takes a little longer because processing it itself takes a little bit of time before the actual operation. Fair enough, it has run. So let's go back and check at the results. Fine, let me go ahead and refresh this. So what has happened is there's a schema called data validation which has got generated, and I have two tables. What is the data type validation? Because the moment you run a Python model or any other model, because the materialization strategy is a table, it is going to create a table of the same name, right? So that is what the data type validation is, and there's a log table. Now, if you look at the log table, let's go and open it up. Do I have some select statements out here? I think I have some select statements out here. Validation log, data validation log. Yeah, right. If you look at the data validation log, it will show you step by step what it has actually done. Each and every step it has actually done and each and every function name. This will be becoming more clear when we do the code walkthrough in the next section. And you can see that data type check for annual sales is a pass. Okay, because we did not make any changes. That is why it is a pass. Now, if you go to the next one, which is the data validation, you'll see the same copy of it. Okay. You can see annual sales validation. You have a status as pass, and you have the column names. Now, if you double click on it, what will you see? You'll see whatever the records which is passed. But then, had it been a failure, then you would have seen the status as failure here, and I would not have displayed all the passes here. I would have displayed only the failures here. Now, I'm not going to put all the columns out here because there are situations when in the enterprise you use OBT, which is like one big table, wherein you have 400 or 500 attributes in a single table, which Snowflake does allow it, right? So in that case, you will end up having all 500 attributes out here. No, I'm not interested. I'm just going to put on the passes, because if it is a pass, people generally do not come back and review it. But if it is a fail, people are going to come back and review it. And when they review the failures, I really do not want to give them a garbage of information and say that, okay, find out what you need. That's the piece. So right now, if I have few more models as a part of my release notes, they would have also popped up over here and you would have seen the status. Fair enough. Now, I'll go to the next model, which is the regression model. And then in the very next section, I'm going to come back again and do a code review, because code review is again going to take some time. Um, if you are really, really passionate about the code review, go ahead and take a look at it. If you want to contribute, fair enough. Please submit a pull request and I'll review and approve it. However, if you want to use this particular package as is in your project, you can definitely use it as you can see it, right? Okay, what is next? Let me go ahead and run the next model. What is the next model? The next model is regression execution. So I'm going to go to my release README and copy it over. Okay. Let's go ahead and clear it up. Sorry. And I'm going to paste it. Regression execution. Okay. And the validation execution, regression execution has started. Okay, one good thing. Maybe some of you will question me, why did I create a log table like that? Because in this log table, it during the processing at each and every step, I'm putting an insert statement. Now, it looks a little weird, because if you are coming from the Python background, you will say, hey, why are you doing it this way? Why can't we use logging? Now, let me tell you, there's no easy way of logging Python models in Snowflake. You can use Snowflake event tables, but then the problem with event tables is that there's only one event table for the entire account, and you have to put a lot of filters on the event table to find out which is the set of events that you are interested in, right? So the easiest way is to go and log into a log table. um, I'm not sure what Snowflake is going to do in the near future about the event tables. If they can create an event table per database, then it's going to be very, very useful. But right now, because it is at the account level, I did try it. But then when I am working in a multi-development environment, there are too many events, and it really becomes a pain to select the event that you are really interested in, right? So at this point of time, the regression model has also got successfully executed. If I go here, you will see that, okay, the regression model has also got executed, the regression execution and the regression log. And there's a table in which you can see annual sales by region. So the way this entire package is created is that, for every database or data model for which you are going to perform the regression, it is going to create a similar kind of a table in the validation schema, which the result set. Because I don't just want to leave the developer with an information saying that, hey, regression pass or a fail. If it is a pass, okay, fair enough. If it's a fail, it becomes more important for the user or the developer to find out what has actually failed, right? So let's go back and see. I'm going to run this. I think somewhere it's going to be there, right? There's going to be the regression execution. Yes, I can see the regression execution. So if I run this, you can see all the steps that it has performed, right? As I was saying, it is going to say all the functions, main, finally. I'm going to take you through that process in the very next section again, as I said. So list of models performed, you can see list of models processed regression. So this is the process. Now it is not going to tell you whether it's a pass or a fail. I'm going to come back there. Now I'm going to run the next model, which is a regression outcome. So what it does is Let's say you have a bunch of models, you run it for your regression execution. It ran through all the models and it is going to save it, the results under each of those models under your validation schema. And when you're going to run a regression outcome, it's going to aggregate it and tell you whether the total process is a pass or a fail. Let's see that. Perfect. Now it's time to do some SQL query. So what I'm going to do is regression validation. Then you have your uh, let me start writing it out. Okay, becomes a little easier. Now, if you go to this table, select perform validation regression dot regression outcome. If you see it's true, that means it has successfully passed. Because we have already identified the column name that has changed, and as I said, that particular column name was not a part of your regression. So the intent of regression is to ensure that whatever has changed should not have impacted the existing functionalities. So performance tier was the attribute which has changed. Again, just to recap, if you go to your release notes, performance tier was the attribute which has changed. Apart from performance tier, everything else remains intact. There's nothing changed. That's the reason you've got true out here. Okay. Now, let me take a look at this table which got created out here. Annual sales by region. Select star from dot annual sales by region. You will see the data frames are equal. So it has taken the dataset from the March schema. It has taken the dataset from the March underscore regression schema. It has compared them using the pandas compare. It has found out that yes, the data frames are equal, and it has given you the result. Had there been a difference, it would have highlighted those differences out here. Fair enough. I think that's a good stop from a demo perspective. But then, as I said, we have to do a thorough code review for the new models which I have created. So let's head over to the next section wherein we are going to do a thorough code review. Right. So I'm going to close these, clear this up. I don't need the terminal anymore because I'm going to do a code review. First, the data type. So how am I doing a data type validation, right? It's a big SQL, okay? So I'm going to run it through the SQL. So what it does is it goes to the information schema for columns, picks model, the model which is changed, and the schema. And what it does is picks up the model and the schema for those attributes which are existing. So you have to understand, you have your March schema where you have a table, and you have your March regression schema where you have the same copy of the table. Now, you pick the metadata from your March schema and match it with the metadata with your March underscore regression schema, and then you find out whether anything has changed or not. That exactly does. So I have the reference CTE, then I have the current CTE. It joins these two based on the column names. And finally, what it does is it checks the data type references. It takes the precisions because it's not just the data type alone. It is all about the precisions as well, because numeric 38,6 and numeric 38,10 makes a lot of difference. There can be truncation issues. There can be data mismatch issues. There can be round off issues. So those are the things which we always have to be careful when, especially if you are working in a finance data product, right? And it tells you it's a pass or a fail, and based on that, you have a data type match. Now, this is the crux of it. This is how the schema comparison is done. But there's a little more to the left and right of it. There are few important functions. As you can see, there is something called a log message, because this is what is logging into the underscore log table. And as I said, I could have used event tables, but personally speaking, I was not very happy with the way the event tables gives you the result. It gives you a clutter of information, and then you have to write a lot of filters to filter it out, to filter what you need out, right? The final result, because the final result needs to be curated by you so that it is stored in a table format. I have a parse release notes. Now the parse release notes function is common between the next module as well. So what it does is it picks up the release notes. It's a JSON file and it parses it through. Now I'm not going to get into the entire details of it. You can very well understand, or you can use cursor or plot to understand this particular code. Then I have the check schema and the config file existence, because for the models to successfully execute, it is very important that the two config files, which we just saw in the previous section, right, exists. If it doesn't exist, or if it is malformed, then your models will not work. So this is kind of a guardrail which checks that before even the model executes, your config files and the schema exists, right? As you can see, check for the schema existence and check for the file existence. In case there are multiple files in your stage, for each category is always takes the latest file. Then you have the data type validation, and I think that's it. And then you have the final model. You cannot write a main function while you write your Python DBT models. This particular model function behaves like your main function, wherein you have your pre-checks, where you are going to check for your schema checks. Then you have your release files config, and finally it iterates over the entire release notes file. So right now the release notes has only one element. It has only one element. However, if it has multiple elements, what it will do is it will try to see that whether this particular element exists in your regression configuration, because you have to understand regression configuration is one time. However, release note can change from release to release. So your regression configuration can have 10 elements. However, in a particular release, you can have 1, 2, or 3 impacted models. So what it is going to do is it is going to take the list of impacted models, go to your regression configuration, and try to find out, does it exist or not. If you are changing a model which is not there in your regression configuration, it is going to skip it from the rest of the processes, because the model thinks that, okay, fair enough, this is not a candidate for regression. Like, for example, if you change anything in your staging model, it will assume that it is not a candidate for regression at this point of time. However, you can always change your configuration and you get things started. So here we are on the regression execution. Now the regression execution is a little complex piece. However, there are a lot of overlaps between the previous model and this model. Like, for example, the log message, then the parse release notes. Now you can very well say that, hey, Rita, where is the code reusability? Why are you not creating a class package? Why are you not reusing those functions out here? Because DBT Python models do not support modular execution. It is a stored procedure, and it expects everything to be bundled in that stored procedure today. I think maybe in the near future things might change, but then you do not have the flexibility to share code units between two DBT Python models, right? That is the reason you have to rewrite it again. I know this is not the ideal way of programming, but then if you have to use DBT Python models, that's how you have to do it today. Fine. Next, you have your Python pandas command. Now, here in the release execution process, I am not using SQL. I'm using pandas, because the final difference that it's find out from the two different data sets, which is there in your mart and your mart underscore regression, it uses pandas underscore compare. right? So that is the reason I have a separate module to create pandas command for each and every element which is there in your release notes, so that it's like, it's just a separation of duties. You have one function that creates the pandas command, because the pandas command creation is very, very important. Because I'll tell you the pandas command, why is it important and why is it complex? Because during the course of entire pandas command creation, it uses this. Because if you have a schema, if you have a filter, if you have an operator, if you have a column name, and if you do not have sortings mentioned, the entire thing is going to go for a toss, right? So you have to sort the pandas command for all the columns in order. That is the reason the regression execution is a little complex process. Well, I cannot go line by line. I would sincerely request you to spend some time to understand it if you want to contribute and you want to upgrade this. Now, I'm not saying that this is the best way of writing it, but then I am sure there will be more optimizations that are possible over here. Maybe I'm going to do that in the recent future. But then if you find out time and if you find that these optimizations are going to make your life easy, please go ahead and make it and leave a comment in the comment section, because I want your contributions to this repo to be highlighted. Okay. Moving forward, I have the save regression result, because as you know, I'm going to save each and every regression result in the same table, just in a separate schema in the validation regression schema, right? I have the check schema check and config file. This is something which we have already gone through in the previous model. And then I have the main model, which is the DBT model, where I have the pre-checks. Then I have the parse release nodes. So the parse release config, it goes one by one. Each and every release node line item is reviewed, checked against your configuration, and processed. Finally, here is your regression outcome. So the regression outcome has nothing to do with your validation. Regression outcome only aggregates the information, or I would say assimilates. There's no aggregation as such from a SQL perspective, but it assimilates the information which it gets from the regression execution. So what it does is it removes all the regression. So if you see here, there's a pattern out here, right? Among the table names, there's a pattern. So what it is doing is, you can see the pattern is for all the regression stuff, it's underscore regression underscore something. And for the data type stuff, it is data type something. Now, the regression outcome has nothing to do with these data type things. And it has nothing to do with the regression tables as well. It is only interested in the model table, in the table names which are having the model name, right? So that's why it says not like regression and not like data type, and it gets all the models, and then it goes over all the model data, and it finds out whether it's a pass or whether it's a fail. If it's all pass, only then the final result is going to give you true, and if it is any one of them is failing, then it is going to give you a false. The main reason for using regression outcome is because I'm going to enable you to use it in your pipeline. Now, see, when a human like you and me are using it, I don't need the regression outcome to tell me, because anyway, I'm going to go to each and every table and find it out. But this comes into action if you have to enable this particular entire process within your CI pipeline. Your CI pipeline should not merge if your regression fails. That's how ideally it should be. Now, it depends on how critical your project is, how critical your DevOps process is. Do you really want to stop your CI merge because regression fails? Well, in an ideal situation, you should do it. Okay. I think that's it. Thank you very much. And thank you for being a lovely audience.
That brings us to the end of the session. I hope you have thoroughly enjoyed it, and if you have found this helpful, request you to leave a comment in the comment section. I would love to hear about your experiences. The code is already open source, available on my GitHub account for you to download, explore, upgrade, and use it at your discretion. Before I log off, a gentle request. Please don't forget to like and subscribe, because tiny gestures like this from audiences like you motivates content creators like us. Thank you again, and see you soon.